Hi, everyone. So we're going to have our next speaker, Jason Perlow. He's going to talk about more than a search engine using tools and structured outputs to get the most out of your chatbot. This seems interesting.
Okay, cool. Hi, everyone. So yeah, thanks for coming to my talk. So I'd just like to go over some of the lessons learned in a project that we've been working on at Asazi, the company I work for. So what would be cool is if you could take some of these ideas from the lessons that we learned and use them in projects of your own. Okay, so I'm sure many of you are wondering, okay, is all this like complicated stuff, structured outputs, tools, what is that exactly? So what is this talk actually about? So the answer is chatbots. Yes, that's right. Yet another talk about chatbots and language models. So this obviously like builds on the previous talk, but this talk is a little bit different. So basically, here, instead of just pulling information, we're going to build on that concept, and also, so like with the RAG that we just heard about, we're also going to not just pull information, but also push information, and in a way that is safe and reliable. So as we just heard about, language models, they hallucinate, they do all sorts of strange things. So how can we actually use a language model to write as well as read in a way that we can rely on? So the approach that we took, as we see later on, is using tools and structured outputs. This helps us like a lot with solving that problem. And as a practical example of this, I'll be talking about a data capture pipeline that we've built at Asazi, and in particular, a chatbot that we built for this data capture pipeline. Okay, so just first I'm going to go over a bit of theory, and then we'll get to the chatbot later on. Okay, so just to step back a bit. So it's interesting, but language models have what's known as a knowledge cutoff. Language models are trained up to a certain date in time. You ask it about something after this date, and the language model won't really know the answer. So it's interesting, but you can actually go onto like ChatGPT's website, and you can type in, when is your knowledge cutoff? You can actually try this if you want. And what's interesting is, so ChatGPT, if you actually ask it, it will tell you that it's around about a year ago, just more than like a year ago. And for Gemini, it's a bit more than 2 years ago. So this is like a universal problem that language models have. So the question is, what do we do if we want to ask the language model about something after this knowledge cutoff? Say we want to ask it about something that happened right today, like the weather in Joburg or some current sports event. What do we do? And the answer, of course, as you may have guessed already, is what are called tools. And so what are tools exactly? So tools are basically just a list of functions that the language model can call. So for example, this could be a call to a database to get more like say user statistics. It could be a quick web search to get like say current information about some news event. It's like, it can really be anything, and we all, like most of us are developers here, it can be anything. Hard to overemphasize that it can be anything that a function can do. We can use it as a tool. So, I mean, if we really want to get crazy, I mean, you could even call like another language model, even if we really wanted to do that. And so it's anything that a function can do. And this adds, or once the function has been called, it returns information back to the language model, and this gives the language model more context to work with, or more information. And that, together with the user query, is what allows us for the language model to actually answer the question appropriately. Okay, so we're all developers here. We might be wondering, okay, but how does it actually do that? It's all good and well in saying that, okay, it calls these functions, but how does it even do this exactly? So the answer is that it basically generates like a little string. It's a JSON object or a Python dictionary, depending on which way you want to think of it. And in the Python dictionary, there's a function name and then a list of arguments to put into the function. And how this actually gets so the language model itself doesn't make the function call. There's a library built that you're using to call the language model, and that library is what actually makes the function call. So when the library sees this particular string or this pattern, then it actually executes the function call and then returns information back to the language model to give it more context. Okay, but here's an idea. I've been talking about using tools to pull extra information, but here's another way of doing things. What happens if we don't just get information from these functions, but we also use it to write information? And in particular, we could even do something quite interesting, like writing it to a database, one of the core components of a software system. So now this is where things get interesting. So I've just told you about tools, but there's something very closely related called structured outputs. And structured output is a lot like a tool. It's almost like a generalization of a tool. So it's basically a generic JSON string or generic JSON object or Python dictionary, depending on which way you want to think of it. And it can be really anything. It could be, a list of colors of the rainbow or whatever you want. It's just like a nested structure of like dictionaries and lists and objects. Okay, so the thing is that structured outputs, unlike tools, it doesn't have to have a function name, and it doesn't have to have a list of parameters or arguments. But the interesting thing is that it can if we want to. So this is one of the cool things about structured outputs, and one of the things that I'll be emphasizing quite a lot in this talk is how you can get a structured output to actually perform the role of a tool. And the reason why you want to do this is because you can shuffle around this information around your software system. So a tool, usually it executes the function in the same place where the API query to the language model is made. But here you can actually defer the execution of the function to somewhere else, anywhere really in your software system, because it's just like a chunk of data that you're sending around the software system. For those of you familiar with like callbacks, it's sort of like a similar idea where you're treating a function as almost like a piece of data that you're shuffling around the software system. Okay, so just to step back a bit to see like why this is important, consider this example. So I went on Gemini, which is a popular image generation language model, and it can do a lot of things, including like image generation. And I typed in, generate me an image of the Johannesburg skyline. So since we are in like Joburg, and we get something that looks, if you had to try this yourself, you'll get something that looks a little bit like this. So for those of you from Joburg, you'll see that, okay, it looks like pretty reasonable, but there's like a few details that aren't really quite right. If you look very closely, I don't know if you can really see it in this image, but there's like a big rectangular building there, and it says like Ponty City or something on it. So for those of you from Joburg, you'll know this is like very famous building in Joburg. It's not rectangular, it's definitely like cylindrical, very famously cylindrical. So they like kind of messed it up a bit. So it's overall pretty good, but it gets a few details wrong. And so this is where human verification comes into the picture. So basically, a human, in this case myself, basically looked at the image and then I edited it. So basically what I did is I just went into an image editor and then I scrubbed out that Ponty City like text. And now we have something that's actually pretty reasonable. So the output of the language model together with human verification is what gives us something that's actually fairly reliable. Okay, so now back to the structured outputs. So in our software system, we're probably not going to be working with images. We're just going to be working with generic data. So now what happens if we send this structured output to the user to verify? This is what allows us to actually use this information and send it to the database in a way that's like reliable and we can actually like use. So number one, because it's structured, we can parse it easily. Our system can work with it. And then number two is that the human has verified it. So the contents is actually like accurate. And those two things together is what allows us to be able to send something coming ultimately out of a language model into the database. It's like quite a radical idea, but it is actually possible. Okay, so now I've gone over a bit of the theory, and now we're going to talk about the implementation of this. So at Asazi, we've been building this chatbot called Ava, and Ava is what, of course, as you may have already guessed, is what uses the tools and the structured outputs. But first, before we go into detail, let's talk a little bit about, so let's just talk a little bit about like what we're actually doing at Asazi. So there's two major components in the software system we're working with. So one is there's a data capture system, and then two, there's a business rules engine. So the data capture system, basically how it works is you've got like a document, and there's going to be, so in red, you have like your name and your address, and then in green, you have the fields that you want to extract. So we're not going to be going into detail about that. Ava is mainly for the business rules engine, but it's just important to bear in mind what gets fed into the business rules engine. That's why I bring it up. Okay, so there's lots of different business rules that we deal with. One example is, you could check for like the presence of different fields. So say if someone fills in their first name, you also got to fill in the last name. You can say, is an amount greater than a certain threshold? There's all sorts of rules that can get executed. But in this talk, we're going to be talking about a certain kind of business rule, namely as what we call like workflows. So basically, you have like a set of steps that the document has to go through. So in the top left, you have like the first step, and then the bottom right, all the red nodes on the right, those are the steps that, once it reaches completion. So here's an example of where so we've extracted the information, and then now it has to pass through all these different steps. So here's like an example of actually like that information going through. So it starts off at the FATCA step, then it goes to the KYC step, and then finally it reaches the completed step. This is obviously only one of many different paths that it can go through. I mean, at each step there's like a branch that takes place, and it can go through to multiple different steps. In case you're wondering like what this is for like one of our clients. It's basically like what we call like FICA in South Africa. So as you may have noticed, this is a little bit like a to-do list. Basically, we're just keeping track of where the information from the document is going. So to repeat the same example again, we first have the FATCA step, then we have the ML step, and then finally we have the completed step. So as I mentioned earlier, like what we have here is these workflows, and it's basically like a type of like to-do list. And so we have this international client. They have lots and lots of documents, different document types. They can be like different application forms, etc. And associated with each different document type is a workflow. So we have lots and lots of documents, lots and lots of workflows. How do we deal with this like efficiently? So if we had to do things manually, it would just take like way too long. It would also be like quite error prone as well. So there's got to be a better way. I mean, most of the workflows and the document types are very similar to each other, almost like the same kind of like application form. They have like the workflows have like the same structure. It's the same like sort of FICO compliance check type system that we need to go through. And so there's the same type of connections. There's like the same kind of like dependencies between like the different states. They each have the different structure, same structure, similar sort of nodes. Like surely there's got to be a better way here. I mean, us as developers, we know that as soon as you see like a pattern, it means that we can like automate things. Okay, so and then this is of course where like the chatbot comes in. And so here's an example of us using the chatbot to actually edit one of the workflows. So I asked the chatbot, just delete all the terminal nodes in the workflow, and those are the ones that are shown in red. And at the top of the screen, the user can either accept or reject the change that has been proposed. So us as developers will recognize this is a little bit like almost like a diff in like a text editor. You could say, if any of us have worked with like say Cursor or Ada or one of these like agentic code editors, it's like we have something similar here, except instead of like code, we now have business rules. or workflows in our case. Okay, so to continue the example, on the left, the chatbot proposed the changes, and then the right, once we've accepted the changes, then all the terminal nodes have been deleted exactly as we wanted. Okay, so that was a very simple example. You might be wondering, okay, well, can't we just do that manually? But it turns out these workflows can get very, very complicated, and they can have lots and lots of nodes, lots and lots of transitions, and this is where the chatbot comes in quite handy. So, for example, in this case, if we wanted to change like the SLA of all the different nodes, or all different nodes with a certain substring, then the chatbot could really help us. Okay, so let's just go over the architecture of our system, like how we set things up. So in the front end, we have Ava, the chatbot, which is written in JavaScript. And then in the back end, we have the Python worker together with a Golang worker. That in turn communicates with an Azure ChatGPT deployment and the database. And of course, between all of this, we have our tools and our structured outputs, which is what I've been going on about. So, and what's interesting with the structured outputs is, like I said, it allows you to defer the function call. So to continue the example from before, we ask the language model to delete all terminal nodes, right? So then that little string gets sent to the Python chatbot worker, then in turn gets sent to the ChatGPT instance, and then it comes back with a structured output. And then the structured output goes back into the front end, and the user can accept or reject this diff that has been proposed. And then once that gets accepted, then it goes into the Go API worker, and then that actually makes the database call to like delete those nodes. So notice how instead of the tool being, you might argue, why can't we just use tools to delete the nodes? But that wouldn't work, because then the user wouldn't be able to actually see the proposed changes. The tool is going to execute, the tool will be executed in the same place where the API call is being made, and that is the chatbot worker. Whereas the structured outputs, we can shuffle around this function call right around the entire software system in this case. Okay, so here's just like a little demo of the system in action. So what I showed you was just like editing like a single like workflow, but it turns out you can also use the chatbot to edit like multiple workflows at once. So in this dashboard, it's currently empty. There's no workflows there. And we've asked the chatbot, please copy over all the workflows from another template. And that template turns out to be very similar to this template. So the user has just accepted like the proposed change, and then it processes for a little bit, and then eventually it's just processing, and then eventually now it gives us the workflows that we wanted. So, and this of course is like very useful if you want to copy from like multiple different templates. There's a whole bunch of things you could do. Say copy, give me like all workflows with a certain substring, etc. All different like ad hoc queries you could make here. That would be very difficult to do if you had to do it manually. Okay, so let's just go over some of the technical lessons that we learned. Okay, so so those of you who may be familiar with like agents and tools and that, usually if you want to define like a tool for a language model to call, you need this whole long complicated story with multiple like nested structures, and it's a bit of a nightmare. Surely there's something that's a bit better. So this is where the Agents SDK comes in, OpenAI Agents SDK comes in. So this is one of many different approaches to do this. I won't say it's like the absolute best one, but it's a pretty good one. I hope to convince you. And it's a way of handling these tools and structured outputs in a way that's very convenient. Okay, so how do you actually define like the tool? I've been talking about so much about tools. How do you actually define it? And then using the OpenAI Agents SDK, all you need to do is plop a decorator above the function, and you just need to tell it the function name and a description of the function. The language model can't actually see the function code. You have to tell it like what it's actually doing. Okay, so now as I said before, we use like we're using tools and structured outputs, but when do we use one and when do we use the other? So tools, in our experience, we found are better for like read operations, and structured outputs are better for write operations. So in this example, we're passing like context into the tool, and I mean the reason why it's like better for read operations is because the tool is, you don't need like the human verification. It's like a non-destructive operation where structured outputs, you can shuffle around the information and then you can get the human verification. So in this example, what's interesting, I thought it's worth mentioning, is that there's no like arguments being passed into this function. There's this like context parameter there, but the context parameter the language model doesn't actually see. That's just coming in straight from the front end, and then it's going ultimately into this like DB call. So this eliminates the possibility of the language model like hallucinating. You know, don't leave if you've got the variable in the front end, just send it to the back end. Don't leave the language model to just guess what it is. Okay, and what's interesting is we found, so one way of using like tool calls is you might want to say like give me like workflow 1, then workflow 2, then workflow 3. You know, we're just using like multiple tool calls to get all our workflows. But we found that's like actually a terrible idea. It's a very tempting thing to do, but it's not such a good idea. A much better way is to get all your workflows at once. You're grouping all those operations together. And the reason for this is that the language model actually will it sometimes gets stuck in a loop almost. It will say, give me workflow 1, give me workflow 1, give me workflow 1. It will call the same function with the same parameter, and then it will hit like the limit of the language model library. But if you group these calls together, then it doesn't have that problem, especially when you tell it to only make at most like one call to each function. Then it will just do it in one step, and then there's no possibility of hitting like the limits. Okay, so I've been talking about structured outputs, but how do you actually define the structured output? So in the agents library, basically in the place where you define like the prompt, you set this one parameter called output type. And in this case, we've set it to this thing called an agent response type. Okay, so how do we actually define that response type? So we use this library called Pydantic. Pydantic is not an AI library. It's just for a way of introducing typing into Python, strict like typing into Python. Python is like incrementally typed or dynamically typed, and Pydantic allows us to have like strict typing in Python. And this, it turns out, is very useful for defining structured outputs. So in particular, you use something called a Pydantic model. A Pydantic model is basically just like a dictionary, essentially. For those of you familiar with like C structs or Golang structs, it's almost like exactly the same thing. In fact, on the right, you can see that's actually like a C struct, and then on the left is the Pydantic model. So they even look like very similar to each other. And what's interesting is you can force like the different fields to be integers. In this case, you can give it default values, you can give it optional values, you can even like nest sort of structs inside each other if you want like hierarchy. There's a lot of different things that you can do there. Okay, so in conclusion, structured outputs give us something a little bit like, for those of you familiar, like contract programming. So we have like a border almost between the language model and the rest of the software system. And it enforces what they call like deterministic serialization. So we can actually guarantee what the output of the language model is going to be. But the thing is, we don't really know if the content is accurate or not. We just know that it's like type safe. So this, together with user approval, is what allows us to control one of the core components of our software system, namely the database. So once the user approves what has been proposed, in the case of the chatbot, it showed you it was that diff that was being proposed. Once that is accepted, then we know that the output of the language model is actually accurate, and we can send it to the database. And this allows us to do something quite radical and bold, really. You know, we've been hearing about language models. They like hallucinate. They do all sorts of strange things. I mean, how can you allow it to control the database, one of the core components of our software system? But it turns out using structured outputs together with human verification, and structured outputs allow us to like do this because we can pass it through the system. We get something that is very reliable and very accurate, and we can even use it in an enterprise software system. Okay, so in the end, we have not just answers coming out of our language model, but also actions coming out of the language model. And we will have, in the end, a happy database and a happy software system. I hope you learned something, and thank you for listening to my talk.
Yeah, thank you so much. That was interesting. So we have probably 5 minutes for questions before we head for lunch.
I just a good presentation, by the way. So I just wanted to know if you have a case where a tool or a function requires another function to be able to run, how many round trips are you doing to the LLM? And also, are you hosting it, pre-training it, or are you using like a wrapper for something like, let's say, ChatGPT? I'm asking this for scale.
Yeah, so to answer your second question, I don't know if I quite got your first question, but yeah, we're not pre-training it at all. We're just using an Azure deployment of ChatGPT straight. I think it's like ChatGPT 4.1. So we're not doing any like fine tuning or anything that it's just, I mean, the prompt, I mean, out of interest is like quite complicated. That's almost like fine tuning it. You got to like specify all the like edge cases and that sort of thing. So there's like a bit of work. You can't just like use it like straight out of the box. You have to do a bit of like prompt engineering to get it to work well. Okay, I hope that answers your question. Yeah.
Hi, good presentation again. My question is around your structured outputs. I suppose more on a life cycle, on the life cycle's perspective of it. It seems to me that the process of defining a good structured output is something that may require a bit of domain understanding, and there may also be an element of like tight coupling between two systems. So how do you, what's the management life cycle of the structured output like in an enterprise architecture where things might change over time? How do you version control the structured outputs to deal with whatever domain you're operating in?
Okay, so that's like a very good question. So, so how do you like manage it? So you, as I said, you got the structured output that's flying around like the whole system. How do you deal with it properly? So, I mean, unfortunately, yeah, you're like dealing with different like subcomponents, different microservices, different programming languages, and it's like, how do you? I mean, basically, you got to. I mean, it's like, say you have a front end and a back end. It's like the same sort of question. Like, how do you, if you're sending like a structure to the back end, like, how do you, like, have it that it like once you change the front end, how do you change the back end as well? So, I mean, it is like basically like a limitation. I'm going to be honest with the system. So you'll just have to change it like manually. You'll have to maybe ask like a language model to change it for you. Hopefully it'll be able to find like all the occurrences of where if you want to add like another field to the structured output, you'll have to add that field in many different places. Yeah.
Thank you. One last question.
I just got a question about how you would probably, maybe a little bit left field, but prompt injection is like a real thing, especially with the chatbots. If you're giving it right access, sure, there's a contract almost that's saying it should meet this criteria, but is there any other preventative measures you're implementing into the chatbot to prevent something like a prompt injection that has malicious behavior? Or
Okay, so yeah, I mean, in terms of like prompt injection, I mean, in terms of security stuff, I mean, so the language model, I mean, it just outputs like integers in this case. So it's going to be like node IDs that need to be deleted or added. So I don't think that's like too much of a concern. But yeah, you raised like a good point. Like you don't want the language model to ever like generate strings because that can like just cause all sorts of trouble. So yeah, you just stick to like integers and should be okay basically.
Thank you so much for taking your time to speak to us. Another round of applause for him.